Hello and welcome to a demonstration of generative AI and ML based actionable insight generation with ABot AI. I'm going to take a couple of minutes first to discuss the capabilities of ABot AI. Given any artifact from network, ABot AI can perform in-depth analysis and identify the specific 3GPP call sequences. Driven by augmented intelligence, ABot AI can perform deep packet inspection, use novel and classic ML algorithms to detect anomalous behavior in the network, and provide actionable insights on network communication guided by generative AI. Let's first understand what is an anomaly. An anomaly is any out of the ordinary behavior in the network. Given an artifact like packet capture from network at a specific point in time, ABot AI will extract the sequence of messages from the TCP dump. Next, it will use a novel sequencing algorithm with a 3GPP powered model for procedure identification. This ML based model is augmented with 3GPP knowledge to correctly identify and classify procedures from the identified sequence. Having completed 3GPP call sequence identification, ABot AI uses a pre-trained novel model bank to detect anomalous behavior. Note that this pre-trained model bank is adaptive in nature, that is, it can learn from its environment to detect customized outliers. Using AIML, ABot AI successfully points out anomalies within the network traffic. ABot AI, powered by generative AI and 3GPP specifications, uses both packet captures and network logs to analyze and determine actionable insights for any anomalous behavior in the network. We have already discussed the mechanisms of the PCAP analyzer. The log analyzer takes input from several sources to correlate and analyze logs from multiple NFs for any derived context. Once both analyzers have performed their functions, ABot AI uses LangChain based multi LLM analyzer and RAG to perform error diagnosis. Once an exhaustive analysis is completed, ABot AI also summarizes the insights to make it more compact and comprehensible. This is how ABot AI combines the powers of multiple language models as well as retrieval augmented generation to generate PCAP and log based actionable insights. Now let us look at a few interesting live cases. Let's analyze this 4G case of initial attach rejection. Here, eNode B had sent an initial attach request to MME. MME, instead of accepting the request, responded back with an attach reject. We have already collected the artifacts for this case. Let us run them through the pipeline. This is how the pipeline will look. We will go through each stage as we see the live execution. Let us now execute the 4G case. Here I am uploading the artifacts. We have uploaded the artifacts in the pipeline, processing through the PCAP tracing stage. We have proceeded to PCAP correlation. Once we have completed PCAP correlation, we have started with procedure identification stage, completed procedure classifier and prompt generation stages, and now we are querying the LangChain framework to get insights on our packet capture. We are now querying the LangChain framework with our logs. Once this is complete, we will consolidate the insights and show the results. We have finally consolidated the insights. Now let's go through them. First, we have an issue that was encountered once for this particular IMSI. The consolidated insights clearly indicate that there was an IE with invalid length. Let us deep dive into the errors further. This is the main issue identified from the PCAP, which says that a particular IE had invalid length. That particular IE was contained in a message that was being transported from S gateway to MME through S11 interface. The following dependent errors were also observed. First, we had an invalid length issue with some information element, which presented itself as a request rejected by serving gateway or PDN gateway when it was transported back from MME to eNode B through S1 MME interface. This framework can not only capture the root cause of the failure, but it also indicates the propagated issues that had stemmed from the original failure. Let us look at a couple of more logs for this case. If you see here, it clearly says that there was an unexpected message interrupt caused by this invalid length of an information element. This wasn't the only issue that was observed. We also saw that this particular issue was encountered twice for unknown MZs. The summary says that this error is typically associated with eNodeB not recognizing the provided UE's S1 AP ID, which prevents it from releasing the UE context. If we deep dive into the issue, we will see that the actual inference was unknown ENB UE S1 AP ID, as mentioned in the summary, and this particular issue had occurred in a message being transported from eNodeB to MME through S1 MME interface. In all, we identified three total issues in this artifact. One for this particular MZ and two for unknown MZs. Here we have the case of PDU session establishment rejection. After a successful completion of initial registration between ABot GNodeB and a commercially deployed disaggregated 5G core, when a PDU session establishment request was sent, instead of a PDU session establishment response, the core responded with a rejection message. I have already selected and uploaded the relevant artifacts. Let us analyze them with the ABot AI pipeline. We are proceeding through the same steps again. We have uploaded the artifact, traced the PCAP, correlated the packets to form an UE-based call flow. Post PCAP correlation, we have completed procedure identification, procedure classification, and prompt generation. Queried multiple LLMs as well as RAG to create insights from both PCAP as well as logs provided in the artifact. Consolidated the insights. The summarized insights clearly indicate there is a bad SQL grammar exception, and the logs also show an error in relation to this particular element. If we deep dive further, we will find the actual issue identified in the packet captured. In the PDU session establishment procedure, we had a particular information element within a message that carried the request rejected indication due to unspecified reasons. This message was being transferred from the AMF node to GNodeB node through the N1-N2 interface. If we look further into the logs pointed out by ABot AI, we will see both SMF and AMF logs gives this bad SQL grammar nested exception indication. Since we have worked with the team responsible for maintaining this core, we can actually say that the issue hinted at here by ABot AI is in fact the actual reason for failure. Once this issue was resolved by the team, this particular case of PDU session establishment was a success. Next, we have PDU session modification rejection. After initial registration and PDU session establishment, ABot GNodeB was attempting to modify the PDU session by sending a PDU session modification request to the commercially deployed all-in-one private 5G core. However, instead of responding with a PDU session modification response, the core rejected the modification request. Here again, I've collected and uploaded the artifacts. Let us analyze them using ABot AI. After checking out the ABot AI pipeline, we have uploaded the artifacts. The stages will remain same as before. We will proceed from packet tracing to PCAP correlation to procedure identification, classification, prompt generation, and querying the RAG and multi-LLM based LangChain framework for insight generation. Here's a first glimpse of the consolidated insights. This particular issue was observed once for this MZ. The summarized insight report indicates a failure in the P2 session modification procedure, which was rejected by the network. A deep dive into the issue shows that it was indeed the PDU session modification procedure that had failed, and the cause of the failure was a network failure in a particular information element carried in a message being transported from AMF to GNodeB through the N1-N2 interface. Looking at the various logs identified by ABot AI, we see the issue indicated in the SUT log as failed to find SM context with NSMF ref 170. Let us look at another case. Here we are trying to terminate an established PDU session. For that, ABot GNodeB has sent a PDU session termination request to the all-in-one P5G core. However, the core has rejected the termination request and responded with a NAS downlink transport message. Let us analyze why. The ABot AI pipeline follows the same stages as before. The consolidated insights indicate the issue was encountered once for this MZ, and the issue was a failure in PDU session release procedure due to message type non-existent or not implemented, which is also indicated in the detailed error report collected from the packet. The same issue is captured in the log as well. This has been a glimpse into the capabilities of ABot AI. Powered by generative AI and ML, ABot AI can ingest network traffic, perform exhaustive error diagnosis using multiple large language models and RAG, and provide holistic and comprehensible actionable insights. Thank you for tuning in.